Okay, in this video, we are going to be doing problem set number 13. There's a link to the problems in the description, as well as a link to a playlist of all of the problem sets. So let's get started and see how we do. All right, number one, the position of a particle is given by y of t, so it's like moving up and down, is equal to -6 natural log of t plus 1 plus the quantity t plus 2 squared all over 2 for t greater than or equal to 0. We want to find displacement, distance, and then approximate position at 2.1 using a tangent line, basically. Local linear approximation is tangent line. Can't stress that enough because I don't stress that enough. All right, displacement. I always think displacement is the easy one. Distance is the hard one. So displacement is just where you ended up minus where you started. So for that one, I'm going to just do this. So I need to do y of 3 minus y of 0. Y of 3 is going to be -6 natural log of 4 plus 25 over 2 when we plug in 3, minus the quantity. I recommend you put parentheses around the first and the second thing when you do this. It's just cleaner. You'll make fewer mistakes. When you plug in 0, you get -6 natural log of 1 plus 2. Natural log of 1 is equal to 0, so that's actually going to be gone. So when we simplify this, we're going to get -6 natural log of 4, and then 25 over 2 minus 4 over 2, so plus 21 over 2. All right, that's A. Distance is more annoying, right? So for distance, we need to know if the velocity changed from positive to negative. We're going to have to find the derivative, set it equal to 0. That's going to be the most of the task here. So I'm going to start by finding y prime. So -6 over t plus 1. Remember, the derivative natural log of u is 1 over u times du, I guess. So the derivative natural log of t plus 1 is 1 over t plus 1. And then, you can either chain rule or expand, whatever. You just get t plus 2. I think you should definitely chain rule that, by the way, to get t plus 2. We're going to set this equal to 0, and then we're going to try to solve. And by try, I mean, I don't know, I wrote the problems, and I tried to make them work out, but, there's no guarantee. Here, I'm going to expand. I'm going to move. Forget that I didn't put a negative there. I'm going to move everything to one side, then I'm going to try to factor. All right. And then we get our zeros. Now remember, it's t is greater than or equal to 0. So really just from 0 to 1, and then from 1 to 3 is what we need to worry about. I don't want to worry about it though, so I'm just going to throw absolute value around it. I'm going to say the absolute value of y of 1 minus y of 0, so that's our change there, plus the absolute value of y of 3 minus y of 1. And the absolute value takes care of the fact that maybe the displacement is negative on that interval. And then I just use a calculator because I don't want to be here all day. But you should try to do it by hand and see if you can get 11 halves. Or maybe I'm wrong and you'll let me know. All right, for C, we want to use a local linear approximation at t equals 2. That just means tangent line at t equals 2 to approximate at t equals 2.1. All right, so for a tangent line, we're going to need the slope, which is y prime at t equals 2. And we just plug in y prime's over there in part B. And then y at t equals 2. So we, again, are just subbing in. It's not pretty. We get -6 natural log of 3 plus 8. I don't know what that is. But I can still write a tangent line. I can still approximate it. I'll just get an approximation that I don't know the value of. So my tangent line, I'm going to point slope this thing. So I'm going to do y minus the quantity, -6 natural log of 3 plus 8, which is gross. But it's what you got to do. And then equals 2 times the quantity t minus 2. So for an approximation, we always use the approximately equal to, the wavy equal sign. And we move over that value, so we get -6 natural log of 3 plus 8 plus 2 times 0.1. Since I don't know the value of that anyway, I'm not going to bother simplifying that. I mean, it'd be 8.2, but I'm still not going to do it. All right, next question. Evaluate. Now remember, I don't know if it's true. I wanted to say most, and then in my brain said, hold up. I think most limits that you're going to run into are actually the definition of the derivative, so you just have to look at them and identify that. So the first one, I see the limit as h approaches 0, immediately definition of the derivative jumps into my mind. If it is the definition of the derivative, so we would have f of x plus h minus f of x over h. So it would be f of x looks like it would be tangent. So f of x is tangent. And then I need to find the derivative of tangent because I'm finding the derivative. F prime, the derivative of tangent is secant squared. That's why we memorize them. And then where am I evaluating this? I mean, if you look at it, even if you don't know what you're doing, pi over 6 kind of jumps out. We're definitely evaluating this thing at pi over 6. So f prime of pi over 6 is going to be the secant squared of pi over 6. All right, so then you think to yourself, the cosine of pi over 6 is radical 3 over 2. And so since the cosine of pi over 6 is radical 3 over 2, the secant is 2 over radical 3. Then I need to square that. That'll give me a 4 on the top and a 3 on the bottom. This is going to be 4/3. And remember, that's the answer to the limit. So I don't know how picky a teacher will be or whatever. Maybe go back to the original and write, therefore the limit is this. But that's the idea. All right, so is the next one the derivative? So it would have to be f of x minus, its limit as x approaches a, f of x minus f of a over x minus a. So a would equal 1. I just need to plug 1 in and make sure I get 2. So f of x would be the cube root of 5 plus 3. The cube root of 8 is 2. This is the definition of the derivative, where f of x is, I'm going to use parentheses and then rational exponents because they are superior in like every way. We need the derivative, and don't forget the chain rule. So what, 1/3 the thing to the negative 2/3 and then times 5. And then we're just going to sub in 1. So f prime of 1 will give us 1/3, 8 to the negative 2/3 times 5. So 8 to the 2/3, so the cube root of 8 is 2, squared is 4, but it's negative, to a negative exponent, so it's 1/4. So we get 1/3, 1/4 times 5, so we get 5 over 12. And again, I don't know how picky anyone is, so I'm going to go up here and write it. I'm trying to answer these as if I'm not the teacher, as if I'm answering them for a teacher. But whatever, let's look at the next question. Use the table to find h prime of 2, where h of x is f of x squared. So chain rule, not a big deal. And we're looking for h prime of 2. So first, we got to find h prime. All right, so it's going to be f prime of the inner stuff, which is f of x squared, times the derivative, which will be f prime of x squared, times the derivative of x squared. So that's what we get. Don't fear it. Just write it down. Work your way through it. I'm going to show that step where I plug 2 in for every x. So there you go. Now I'm going to the table. I'm going to find f of 4. F of 4 is 2. F prime of 4 is 5. So I will have my next step be f prime of 2 times 5 times 4, or 2 times 20. It's fine. Now I need to find f prime of 2. F prime of 2 is negative 2. Negative 2 times 20, negative 40. And we made it. This was a long one. Remember, the goal for me is to get them all done in under 10 minutes. I don't know how long they're taking you or if you're even doing them. But anyway, that's the end of this problem set. I hope this was helpful, and good luck.